Good morning, Braylon. Today we're going to be looking at lesson 24. Let me go ahead and scroll there. If you want to get your packet and open it up to that as well, that would be great. I am going to take just a couple of minutes to go over what the lesson is about today. We're going to be talking about this multiplicative property of equality or multiplication property of equality. Either way to state it is correct. But just as an example, let's say we have this equation. 2 is equal to 2. That's true, right? But what if I take this 2 and I decide I want to increase both sides by multiplying by 3? That would give me 6 equals 6, right? So this is still a true statement. Notice what we did is we multiplied both sides by 3. Okay, so we keep it in balance because I'm multiplying both sides by 3. So I'm increasing both sides times 3. Okay, that is, in essence, that is the multiplicative property of equality. What it's saying is that for any real number, let's just say they're A, B, and C, there's my 3 numbers, and as long as A is equal to B, then this is true. I can multiply both sides by C, oops, that should be a B, by C, and it will remain equal. That's what we did up top here. So we have our 2 numbers up here in this one that were oops, I'm sorry, I'm writing the wrong thing here. Oh dear. Okay, well anyway, you can see that this is actually the multiplicative property because if A and B are actually equal, it's the same number. And then we're multiplying both sides by C, which is the same number. Okay, so doesn't that make sense then that you would still end up with a true equation there? So let's look at the next level up on this. So let's say we have this example, 4x equals 12. And I want to figure out what x, the solution for this would be, what would x be equal to? We could, in this case, divide both sides by 4. Remember, the goal is always to isolate the variable. And since 4 is being multiplied with x, we can divide it by 4 because that will give me 1x or just x. So the solution to this problem would be 3. So you can see that if every term on both sides of an equation is either multiplied, or in this case, where we divided by the same non-zero quantity or the same non-zero number, which in this case was 4, then the resulting equation will be an equivalent equation to the original equation. Well, what does that mean? And I remember saying that in the last lesson. What that means is that x equals 3 is an equivalent equation to the original equation of 4x equals 12. Okay, so in this case, 3 satisfies the equation 4x equals 12 and therefore is a solution of that equation. Now there's 2 ways actually that you can use this to solve for your solution. Let's look at this way. I could multiply both sides. Watch what happens when I do that. Because if 4 is over 1 to start with, look what happens. 1/4 times 4 over 1, that's multiplying with the reciprocal, isn't it? And that would also give us a 1x or just an x. Let's see if this turns out to be true. I can cross cancel here, and I end up with 3. So either one of these methods are correct and usable. It's really up to you which is most comfortable. Honestly, for me, this is the most comfortable when dealing with an equation that looks like this, 4x equals 12. But we're going to be using both methods today just to get a little practice, and then you can decide which one that you like the best. So 24.1 in your book gives us this example, 5x equals 20. And they want us to use both methods. 5x equals 20. And 5x equals 20. I'm going to write both down so that we can do both methods here. So the first one, they want us to multiply by the reciprocal of 5, which is 1/5. Remember, using the multiplicative property of equality, you have to do this to both sides of your equation. You end up with x equals 20 over 5, or we can cross cancel, and you'll end up with 4 as your answer. So let's try the other method. On B, we're going to divide both sides by 5 to isolate the variable x, and we get 4. All right, that's 24.1. Let's try 24.2. We're going to do the same methods. We're going to use both of them to solve the same problem. So we have 2/5 x equals 7. Okay, on the first side, I'm going to multiply by the reciprocal, and this is where it comes in really handy. So in this case, I would use the first method where I multiply by the reciprocal because it's already a fraction, and the easiest way to isolate the variable is to multiply by the reciprocal. So we get x over here. Remember, we have to multiply both sides by 5/2. So we get 35 over 2. Let's test it out over here. Here's the long way. I can divide both sides by 2/5. So when you have a fraction with your x being multiplied, this is a little bit longer way. So I would have x equals 7 divided by 2/5. See how it's going to make some extra steps for us here? We multiply by 5/2, and we end up with 35 over 2. But look at all the steps here. And here we only had like one step. So you have to decide when it's best to use the reciprocal and when it's best to maybe not use the reciprocal. And as you practice these, you'll figure that out. 24.3 has 2 1/4 x is equal to 3. And in this case, we are, they want us to use both of these. I think we get to choose what we want to do. So what I would do in this one, I have a mixed number here. So I would bring this down and make it an improper fraction. So you would end up with 9/4 x equals 3. 9/4 times x. Let's use the reciprocal and multiply to isolate our variable. That gives us 1x. We can cross cancel here, and you're going to end up with 4/3 as your answer. You're not required to do both methods unless the lesson is asking you to do it. So on 24.3, I felt like that was the easiest way to do it. Looks like I missed one. We have 24.4. And on 24.4, I did, okay. So we have x over 3 is equal to 9. Okay, so on this one, we have x divided by 3, so we're going to multiply both sides by 3, because look what will happen when we do that. It's like multiplying with the reciprocal of 3 over there, but it's just going to help us to get 1x, because you'd end up with 3x over 3, which cancels those out, equals 27. So the answer to this would be 27. That's 24.4. Let's look at 24.5. This is the last example in the lesson, and then we'll do some practice problems. Go back up to our notes. 24.5, we are being asked, oh, no, we just have two problems here. A, which is x over 2 1/2 equals 7. Okay, so in this case, we're trying to isolate the variable x again. So I'm going to multiply by this term, because if I do that, I'm going to get 2 1/2. Put it in parentheses, that's going to act as my multiplication symbol. 2 1/2 over 2 1/2 is 1, right? But remember, we have to do the same thing to the other side. So I've isolated my variable. Whoa, come back here. 7 times, and I'm going to change this to an improper fraction. 2 1/2 becomes 5/2, and x is going to be equal to 35/2. Did I just do that one up here? I thought I had an answer like that. I did. That was different. Okay. Letter B. The problem is P over the fraction 3/2. All right, so P is being divided by 3/2, so we're going to do the same thing. We're going to multiply by 3/2 because 3/2 over 3/2 is going to end up giving us 1. Oops, I should finish writing the problem here, right? Okay, so those will cancel and make 1P or just P. And don't forget then we multiply over here by 3/2. Let's change 4 1/3 into an improper fraction. We'll get 13 over 3. And we're going to multiply that times 3/2. I have some cross canceling I can do here. And I'm going to end up with P equals 13/2 as your final answer. All right, now let's go back to our notes. Lesson 24 is right here. Right here's your multiplicative property of equality. I notice here though that something's missing and you need to put this in. So for any real numbers, A, B, and C, if A is equal to B, then A times C is equal to B times C. If you can just fill that in, that needs to go right there. All right, so we have our first example, 5x equals 45. We can divide both sides by 5 to isolate the variable x is equal to 9. On the next one, we have a fraction here being multiplied with x, and it equals 6. So 2/5 x equals 6. So this is a good problem here where we can multiply by our reciprocal. If you're more comfortable putting your 6 over 1, go ahead and do that. But this is going to end up as 10 over 10 times x, and 10 over 10 is 1, so those just cancel out. So x is going to be equal to, we can do some cross canceling here. The solution for that is x equals 15. Okay, so let's do, there are 4 practice problems, and you can find those on page 104. The first one, let me expand my sheet a little bit here, is 3/5 x. And you're going to go ahead and do these along. You can pause the video if you like and try these 4 on your own and then come back and see if you did them correctly. So we have a fraction here being multiplied with x. So this is another one of those where we're going to multiply by the reciprocal. We need to keep our multiplication property of equality in mind, so we do both sides. We multiply both sides by 5/3. These will cancel out to make 1x equals, we can do some cross canceling here, and you end up with x equals 45 for letter A. Letter B, the problem is 3 1/5 y equals 32. My recommendation on these, you can divide both sides by 3 1/5, but you're going to end up in the same place. So I'm actually going to show you both ways that I would do this. I could divide both sides by 3 1/5. That's going to become 1, and I'm going to have y equals 32 divided by 3 1/5, which then we need to change this to an improper fraction. It would be 16 over 5. And then we have to use our KFC right here, where we're going to keep, flip, and change. I can do some cross canceling, and I end up with y equals 10. Okay, over here I want to show you why I would use the other method. So we had 3 1/5 y equals 32. I'm going to change this to an improper fraction to start with. So I'd have 16/5 y equals 32. I'm going to multiply by the reciprocal right here. So look what step that is. If you can find it, we're almost, well, actually, let me do this one and then you'll see it. So this is going to become 1y equals 32 times 5/16. So look here, that's the same step. And y equals 10. So this is one way, and this is the second option. prefer this one. Okay, letter C, x divided by 1/4 equals 20. We're going to multiply both sides by 1/4 to isolate the variable, because 1/4 divided by 1/4 is 1. And I can do some cross canceling over here. And I end up with x equals 5. And then on the last example, D, we have x divided by 2 1/4 equals 5. We're going to multiply both sides by 2 1/4. Because 2 1/4 divided by 2 1/4 is 1, so they cancel each other out to give us 1x or just x. This is the step I'm going to take 2 1/4 and make it an improper fraction. So I have 9/4. We're multiplying it with 5. So x is going to be equal to 45/4. And that's the solution to letter D. And that concludes lesson 24. So go ahead and finish the problems that are assigned in the packet, and we will meet to discuss these questions that you may have and check over your answers. Okay, have a great day. We'll talk.